Okay, now for the next part, we're going to be moving through 6 exercises. Your paper is going to look something more like this, so you can still do the work on your own sheet. Mine looks a little bit different because I have copied down the actual exercises onto my paper. For time's sake, I've gotten rid of number 1, and we're going to just do the numbers 2 through 6 that are a little bit more complex problems, but we can keep going at this fast pace, keeping the same consistent formula that we used on the first 2. So let's get started. Jackson so again, number 1, you can just put a line through it. We're starting with number 2. Jackson test drives cars for a company. Part of his job is to test the cruise control on a testing course. On his last drive, Jackson set the cruise control at 48 miles per hour. Okay, we know how to start writing that out. 48, I want to make that look like a fraction. He drove for 2 hours. How many miles did he drive? So we want to double check that our final answer is in miles. So let's see if this works out the way we would anticipate. I want everything to look like a fraction. I see hour, top and bottom. Those can cancel out. And that looks right because when I end, I will still have this unit of miles, and the question's asking how many miles. So that checks out. I've set this problem up right. 48 times 2 is 96 miles. And that is my answer. Multiplied all the way across, this would have been over 1, which would just be 96 miles. Number 3, to train for an upcoming marathon, Alvin runs 9 miles per day. I want this all to look like a fraction. If Alvin runs 9 miles a day for 30 days, how many total miles will he run? So we want to make sure our final answer is in miles. Gonna make these guys look like a fraction as well. Day and days can cancel out. So it looks like the only unit I have left should still be miles. That's looking good. 9 times 30. Well, 9 times 3 is 27. So 9 times 30 is 270 miles. Do this across over 1 would just be 270 miles. Don't have to reduce anything. Or I guess I should say I don't have to simplify anything other than just getting rid of that 1 because it is a whole number here. Anything with a 1 on as the denominator, we know that's a whole number. Okay, the next one. A library just hired Brittany to write reviews on different books. The job requires Brittany to read 3 books a week. I want this to look like a fraction too. If Brittany reads for 12 weeks, how many books will she read? I want to make sure my answer comes out in books. Let's make these guys a fraction. Week and weeks cancel out. 3 times 12 is 36 books, which corresponds with the question, so we know that looks right. 1 all the way across would be 1, so this is just 36 books. Number 5, notebooks are on sale for 4 notebooks, $1. So 4 notebooks per $1. Okay, I want this to look like a fraction. Mrs. Day wants to buy notebooks for her students. She has $12 to spend. How many notebooks can she buy? So I want to make sure my answer is in notebooks. I'm going to make these guys look like a fraction as well. Dollars cancel out. 4, I'm multiplying all the way across my numerators. 4 times 12 is 48. Can't get rid of that. Notebooks. And that corresponds with the question being asked, so we know we've set this up correctly. over 1, which is just 48 notebooks. And our last one, number 6, Kevin hopes to earn a college basketball scholarship. To improve his shooting skills, Kevin shoots 50 baskets per day. I want this to look like a fraction as well. Oh, and in case I'm not mentioning that, when you see a little dot, just to make sure we all are aware, that means multiplication, because we're just multiplying all these fractions. Multiplying this unit by this unit, so multiplication. If Kevin shoots for 60 days, how many baskets would Kevin make? Let's turn these guys into a fraction. Day over days, or days over day, I guess. Those cancel out. So my only unit left is baskets, which corresponds to the question. Perfect. 50 times 60, well, 5 times 6 is 30. And then I add those 2 zeros back, so 3,000. Oops, I don't have enough room. Baskets over, all the way across, I just have 1. So 3,000 baskets. Okay. So our lesson summary, we can convert measurement units using rates. The information can be used to further interpret the problem. Here's an example. So in this example, they're showing that 5 gallons per minute is really 5 gallons over 1 minute times 10 minutes. Minutes and minutes cancel out. I tried to make that more visual for you guys by adding that 1 underneath these so you can really see what's the top and what's the bottom. In other words, what's the numerator and what's the denominator. Going forward, I think that if you just keep this formula, this idea in mind, I feel so confident about your ability to increase the difficulty of the problems, but just stick to this formula and stick to the idea of turning everything into a fraction. Crossing out units that are both present on the numerator and the denominator. You can cross that out. They cancel each other out. So even though, yes, like I said at the beginning, Miss Rondella, I could just solve these by multiplying whole numbers. That's absolutely true. But the complexity going forward, you will thank me for introducing this formula when I did. And just getting used to it now, even though it seems like an extra step, is going to take you a really long way going forward, not just this year, but in years to come. So that wraps up lesson 18. In your problem set today, you guys have number 1 that's asking you to do this same formula with part A and B. And number 2 as well, you're working with gallons per hour being the rate. So make sure when you set that up, you have gallons per hour looking like that. And just try to stick to that idea of turning everything into a fraction. I know you can do it. You're going to do an excellent job. And thank you for your hard work.